were comparing this morning, weren't we? Anyway, comparing. Huh? Comparing. Can be dangerous, true? Can kind of tear down your identity, too. Got to be careful of that one. Comparison is the thief of joy. Is that C.S. Lewis? Sounds like him. It might not be. Comparison is the thief of joy. What does that mean? Has nothing to do with math. Well, it does. Things. Why would comparison be the thief of joy? You realize or you think you're not good? Yeah. Let's not say realize. Well, there went. Too much comparison. There you go. But right? Right? Why do some people, when they are struggling with deep depression, just delete their Instagrams and their Facebooks and their Twitter feeds? Don't want to look at other people's like mess and brokenness and screwed up lives? Oh wait, no, what do we post online? Okay, some of you guys do post a lot of, I don't know, funny but fairly depressing. I don't know. Well, isn't like half the things you laugh at things that are sad in reality? Okay, so that's ignoring that. But as far as people's highlights, don't they post their highlights? So what are you looking at when you look at their whatever? Their highlights. And it might not be their facade. It's just all the good times. Like, do you post the whole like I am in crippling depression right now? A couple of you maybe, but most of you. I know you do. That's why I said a couple of you do. I see yours. But do most people? Comparison is the thief of joy. What I think they have, I wish I had, and I don't, so therefore. Or what I think they have is better than what I have. But then we're kind of ignoring the brokenness that exists in everything. But anyway. Oh, no, it's okay. I don't mind. Is that what you guys... I'm not doing speeches. I'm not qualified to speak. Are you kidding? We're just sharing. We have a little bit of somewhere beneath the brokenness. Comparison. So, here's the struggle. We need to compare rightly. Oh, poor Riley. She's like, what? Rightly. I know. I wondered why you look so quickly. Rightly. We need to compare rightly. And that is the struggle of the direct comparison test. Because, it's okay, I tied it all together. We need to compare rightly. Is it bad to compare? Not necessarily. Whenever I go to a math conference, what am I doing every time I'm listening in a seminar? Oh, I wish I was like, yeah. And to some extent, that's healthy because doesn't that stretch you or doesn't that push you to grow? True? If all of you guys had like a C average, right, in a class, who's pushing for the 100%? Probably not. Now, that's a silly example, but like put it in the workforce, right? If no one's like out there doing something amazing in your company and like accomplishing great things, you're like, yeah, it doesn't really matter, whatever, we all get the same paycheck, you know, right? Or if I never go out and see other math teachers, I'm like, yeah, we're doing all right with my 70-ish% AB passing rate on average. Yeah, it's all right. Some schools have higher, but they also narrow down who's allowed to take it, so. Madame did that. She had like 100% for quite a few years. And then our policy changed. Anyway, so coming back. But I've had kids pass that didn't think they would, so I don't want to keep them from that possibility. I'd rather my percentage be lower and they try than my percentage be higher. But anyway, coming back. Not all comparisons are bad. We have to do comparisons for the comparison test, but we have to make sure that we do it rightly. Look at this. I need to know who's bigger and who's smaller. Look at the entire test. You guys have already written it down, right? I need to know who's bigger or smaller. And here's the struggle. It can't be bigger as in at the end. It has to be bigger along the way. It can't be bigger as in at the end because we don't know necessarily what these are converging to. What's the one type of sequence that we can know what it converges to? Geometric, to the a sub 1 over 1 minus r if it converges. I know that one, but right now that's the only type we know. Otherwise, all we know is converge or diverge. That's it. Converge to what? Something. So how can we compare unless we look at the terms? We have to get into the details. We have to get into the details. Oh, there's a math lesson for that. You can't just compare and be like, I want to be where you are. You have to figure out what got them there and then be like, oh, okay, I'll work on those things. So coming back. That was a good one. That was a good one. So what do you guys see with the if? It's underlined. It's pretty important. Okay, here's the idea. If we don't just have positive terms, we have to go to a different test. There's technically one called alternating, which helps us anytime we have a -1 to that or a sign of that makes it negative, positive, negative, positive. We have to keep those away for a different test. But as long as we have positive terms and, each term is less than, blah, 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 blah. Okay. Can I try to at least sort of show you what this test is saying? If we can say, you're always bigger than you. If we can say that, and sometimes that's the hardest part. If we can say, you're always bigger than you, think about LNs, how you know exactly what the numbers are. If we can say, you're always bigger than you, makes the test hard. Then, ready? Where's the fixed point? My coffee, fixed point. Okay. Let's call that fixed point 0. Cool? Let's say all of his terms, or actually it can be any fixed point. I don't care, a constant, a number, whatever the fixed point is. If I have, think number line. Smaller over here. Cool. If the smaller, but the smaller converges to some fixed point. I don't care. Converges. Think about the bigger. But what if I knew the bigger converges? What can I say about this? Squeeze theorem, basically. If I can say, I'm always bigger than you, if I'm comparing and I want to know what this guy is doing, and if I can find someone higher, bigger than him, that converges, oh, I know what you're doing now. What if I want to know what this guy is doing, and I choose someone smaller that converges? Do I know anything? No. But what if I choose someone smaller that diverges? So, BC, that's what you're in. And also, if bigger converges, I know convergence. BC. SD, it's a card, but besides that, maybe no one uses that anymore. SD, still a thing, right, for cameras? SD, smaller, diverges, I know something. Anything else? I know nothing. Does that make sense? So the guy that I'm trying to figure out, sometimes struggle. So let's say you figure out a bigger, and then you're like, oh wait, but he diverges. Doesn't mean anything. Well, if you figure out a smaller, you're like, yay, I figured out a small. Oh. So part of it's trial and error in the sense of, is he bigger? Okay, is he? One thing will tell you everything, and one thing will tell you nothing. Well, that's why we don't like this one, because direct comparison test number 1, we have to know the bigger versus the smaller. We have to figure that out for ourselves. And then number 2, it actually has to do or go the way that we need it to go to tell us. So just because you choose a bigger and it diverges, does that mean you failed? No, it just means that comparison didn't work. So go find another comparison. Maybe choose a bigger one, try to find a bigger one that does converge, or be like, maybe it diverges, I need to go looking for a smaller. You guys kind of see the struggle? Endeavor number what? What are we on? Sounds right. Only works for series positive, converge. Oh, squeeze in, push out. I don't know. BC, SD, that one's, I think, the one that's basically helped me more. I at first did these, and then I've been using BC, SD more. Because you're thinking bigger, smaller, and then trying to figure out which way. But you can squeeze in, and then you can, a converging can show convergence if bigger, and then you can push out a smaller diverging can show divergence. Here we go. Let's play. Ooh. Remember that whole thing I was talking about with the positive, continuous, and decreasing? Sometimes the beginning might be doing something different, but we care about the forever. Okay, same thing here. The first couple terms might be bigger, but the forever is smaller. We could separate it and just look at the forever and ignore the first couple. There's a mathematical way of doing that. What if the first couple terms are bigger, but then, it's backwards, are smaller, but then the forever is bigger? We can use it still. We just have to kind of separate it to be able to compare the forevers and not compare the entire thing. That's what that's talking about. Okay, here we go. What test? Geo. Not Geo. Why was I excited about Geo for 1/2 second? It's raised to the n. I was like, yeah, r is 1/2. Who ruins it? Oh, stinky +1. Okay, don't be bitter. He's allowed to be him, right? But think about, wouldn't it have been nicer if it was 1/2 to the n? Some of you might be thinking right now, okay, fine, integral test. Why not nth term? Because limit is 0, we know nothing. Okay, keep going. Why not p series? Because it's not an x to a p. First of all, the variable's up there, and second, whatever, it's not a p series. So integral test. Oh, well, we know this one. Why does that help? Well, couldn't you rewrite it to be 2 to the negative n? Oh, because then we could. But what about the +1? Oh, it'd be 2n plus 1 to the, well, that doesn't help. Integral test won't work because you can't integrate it. So, pause, back. Geo would have been nice. That's when you compare. Geo would have been, okay, let's compare. Let's compare to I can do that one. I can do 1/2 to the n. It's Geo and it's converging. Why is it converging? Because r is equal to 1/2, which is less than 1. Why am I thinking all this in my head? Because I don't want to show lots of work if it doesn't tell me anything. Oh. Here's my question. Bigger or smaller? Why? Isn't this guy's denominator going to be 1 bigger every time? 1/2, 1/3. 1/3, 1/4. Oh, the bigger denominator is the smaller number, right? Are some of you already wishing this test wasn't a thing? Wait a minute, but wait. If he's bigger, BC. If he's bigger, BC. Got it, so go ahead and state it. Since the terms of both, we're going to use our little sigma as our series. Series are positive. And guess what the comparison tests make you practice? All the others, because you're going to be talking about the convergence and divergence of the one you're comparing to. Look at this. You're practicing your test twice in one answer.
I don't really get it because this is only going to be why would we use comparison?
There's no other way to do this one.
So like there's none of the other tests that we're going to work?
Well, there might be one other one, but not one that you know now. Yeah? What did I say? I said I could use the direct comparison test because my terms are positive. I showed which one was bigger, and I showed the bigger one converges, so therefore, yeah, my series converges. Done. Squeeze in. The bigger one squeezed in the smaller one. I'm done. So some of you might already be pondering number 2. I'm going to take questions on number 1, but number 2, maybe you're thinking, who should I compare it to? A wise comparison, not a foolish one. Don't worry, if you make foolish ones, no judgment. We're still figuring it out. Wisdom takes time. More life lessons. Questions on number 1? Are we okay? Yeah.
So like what would the answer choices be? Is it just
You'd probably have Roman numeral 1 as a series, Roman numeral 2 as a series, all the way to like Roman numeral 4, and then you have 1 and 2, and 1 and 2 and 3, and 1 and 3 and 4, and which ones converge? Yeah. Probably. Probably. But remember, we're not just working for the AP. I am trying to teach you guys convergence and divergence beyond what they would ask you, but since you guys are wondering. What do you guys think we should compare to in number 2 then? Are you thinking how integral test would be bleh? Nth term test, we know nothing. Geo test, no way, there's nothing to the n anyway. P series. Okay, so let's think about it. That's what we have to do. We have to do trial and error. So Maggie was like, what if we just ignore the, who are we ignoring? Him or him? Okay, so we're just doing square root of n? Okay. So what if we compare to 3 over root n? That denominator is smaller, right? So bigger, right? Because if I take out the n, smaller denominator, bigger number. But isn't that p series? P is equal to 1/2 diverge? Bigger diverge, BD, nothing. But keep going, you see? Okay, so pick something else. What if we ignore the square root of n? Still bigger, right? Uh-oh, 3 over n. Isn't that p equal to 1? P series diverge? Bigger diverge. What if we put the two together? What if we had times instead of plus? So n to the 1/2, so n to the 3/2. That converges, but is it bigger or smaller? How can you know for sure? Yeah. So you could go ahead and plug in 1, so that'd be 3 over 2, right? Plugging in 2, 3 over 2 plus root 2. Uh-oh. Plug in 3, 3 over 3 plus root 3. Okay, I think we'll stop. Let's try this guy. That's going to be 3 over 1, bigger. That's going to be 3 over 2 times root 2. Why don't we get to one that we know? Does that help?
The square root of 2 is like 1.3. So it's going to be a bigger denominator. Well, yeah. Well, 2 plus, well, I don't know.
We know this one, right? 4 plus 2 is 6. 4 times 2 is 8.
Oh, so it's big smaller.
Uh-oh. Smaller converging tells me nothing, right?
Yeah, so this is 2 different.
But then the first term is bigger, so how's that work? Would this be the one we
True. We could have separated that off.
Okay.
And so then, but I saw a smaller converging SD, or no, SC. We know nothing. South Carolina, nope. Not allowed. Similar type? It's hard to compare otherwise. But it doesn't have to be necessarily. Doesn't have to be necessarily. Mostly an n by everybody. But then the problem is n squared plus n. How are we going to do that one for convergence? Or like for our tests? Integral test, I'm not sure I could integrate that one.
Can you explain the S one more time?
We have a comparing dude. If we figure out somebody smaller who converges, I know nothing about him. He's not squeezed in, he's not pushed out. Smaller diverges, I know he diverges too. SD. If I choose bigger, that diverges, I know nothing.
If we find a small one that diverges.
Then that means he's divergent. Or we find a bigger that converges, that means he's convergent.
But the last one,
Because it was SC. The smaller was converging. Because it was n to the 3/2. 3/2 is greater than 1. P series converge. Yeah. Has anybody thought about how this could be rewritten as Does that help at all? Same exact thing, but it's another way of looking at it. It doesn't change the numbers, but it might make you think of a different comparison. Because so far you guys have been thinking of multiplying those two. And we can think of multiplying, but think this multiplication. It'll be easier to compare the denominators. We could. But the problem was 3 over n. Didn't we figure out 3 over n would be smaller denominator, so bigger number, and it diverged. So B, D doesn't help. N squared plus 1?
I mean, n square rooted.
What's inside the parentheses?
Yeah, so just 3 over that.
That'd be a gnarly integral test. We couldn't do P series. We tried this one already, right? And that didn't work. Why didn't our n to the 3 halves work?
How come you can't just do something random like make a geo series like 1 over 3 to the n, and then r is 1 over. Can you just do something like
You could. But if we did, this is converging. And isn't this always going to be a smaller number than that? Because the denominator is going to win. So smaller converging. So you're not wrong. It just doesn't help us in this case. So it wouldn't be a bad idea to take the 3 out. Some of you guys are probably focusing on the 3 too much. Like we could just totally take that 3 out and forget him. We could just do 1s if that helps. Because we could pull, right? He doesn't really matter. What's something bigger that would always be bigger, aka with a smaller denominator and converge? Or something smaller.
just no denominator at all?
3 over n.
Converges, P series, but he'll always be a bigger denominator.
What about n to the 3?
Did you say something that's bigger?
Wouldn't n cubed be converging and always be smaller anyway?
Like n to the 1.3 over? I don't know. Oh, I was... No, wait.
What would that be? Converging, P series greater than 1. Is he bigger?
Oh, maybe. Well, 2 to the 4th is what? Like,
Yeah, it's big. Wait.
What would 1/2 plus to be? That'd be 2/4. 3/4? Is that what it would be? Will that be right? I was trying to compare it to him. I'm trying to see if he's smaller. You think we should do something else? To be honest, I actually can't remember what to compare it to. I've been having you guys help me out.
I know, in the class that you just told us you
I know, right?
Too long.
But hold on, pause. Number 2 is a really hard one. Would number 3 be any easier? Hold on, pause. I'll have to come back to number 2. I actually don't remember what it was. I was experimenting. Why are you guys freaking out? What are we going to compare it to? Yeah, why? Sine squared is always positive. If it wasn't squared, we'd be in trouble because it'd be going back and forth. But sine squared is going to go between 0 and 1, right? And as he goes between 0 and 1, what's going to be true about this guy? He's always 1. Isn't that going to be greater than or equal to? Because sometimes if sine is 1, I guess it would be the same, right? But otherwise, when sine's going down to 0, he's always going to be 1. Why is that a good thing? Because since the series terms are always positive, both of them. Which test? Geoseries. I mean, it's the one we just did, right? Conversion. Thanks, guys. By geo r is equal to 1/2, which is less than 1, then I'm going to go play around with number 2. Actually, I'm not because I have a meeting right now. Bummer. At some point, I'm going to play around with number 2 and then post a solution to them. Why can't I remember how to do them? I think it's 2n. Does 2n make sense? 3 over 2n? 2n. If I treated the square root of n to be a single n, 1n plus 1n is 2n. That'll always be a bigger, yeah, that's it. Oh, why didn't I just use that one? I figured it out. I kept on trying to work with the square root instead of the other. Because 2n is n plus n, so he's always going to have a bigger second piece, and the bigger denominator is a smaller number. Smaller diverges. Haha, there he is. 3 over n plus root n. Since and 3 over 2n diverges by p series p equals 1, which is not greater than 1. Haha. Smaller diverges. Ha. There we go. I don't know why it took me so much time. I got it, guys. Number 2 is on the thingamabob. Who's triggered and why? No triggering. Love.
I got a really nice discount.
Did you?